Welcome to Nonprofit Stories, inspiring tales from Silicon Valley. We will explore the transformative work of nonprofit organizations and leaders who are changing our community by tackling some of the most pressing issues facing Silicon Valley. So without further ado, let's dive into this exciting conversation. Today, we welcome Dr. Yuli K. Chittipalli, a renowned figure with over 2 decades in emergency medicine, an award-winning physician, innovative researcher, and entrepreneur, founder of Sirica Therapeutics, and Innovator MD. Thank you to our sponsor, TradeMyHome.com, for their community commitment and for making this podcast possible. In Silicon Valley, a hub of innovation, autism therapy faces critical challenges. 1 in 36 children in the U.S. is now diagnosed with autism spectrum disorder, yet technology's promise in therapy remains largely untapped. Only 35% of households with autistic children have access to virtual reality technology, contrasting with 72% in other families. Moreover, only 42% of these children receive technology-based interventions, with 23% personalized to their needs. And now your host of Nonprofit Stories, Dee Kiso.
Dr. Yuli, it is so nice to have you here today, and I can't wait to hear about what you have to tell us about cutting-edge innovation and moving forward in our medical care.
Thank you very much for having me, Dee. It's a pleasure to be here and talking about innovation, my favorite topic.
So what inspired you to pursue a career in healthcare, innovation, and in the emergency?
Yeah, when I became a physician and I was training, emergency medicine is exciting, right? You see all kinds of things walk in or sometimes roll in to the emergency department. And so that keeps you going and, in a way it gives you a high. But then after a while, after doing that for several years or several decades, you start to get burnout. And also I was looking at problems that keep recurring. And I was thinking, there should be some solution to this. That's when, we were rolling out electronic health records, a lot of data being collected. And so I got very interested in the technology side of things to help the care process. How can technology make life better for the physicians and nurses, but also make better outcomes for patients? And that's how I got into innovation.
Well, we were talking earlier about your fabulous book, Punish the Machine. And the tagline says, "The Promise of Artificial Intelligence in Healthcare." Can you tell us more about this and why you wrote this book?
Yes. So at my last job, I was doing research, mainly technology-based research. So the idea is how to improve healthcare delivery. And in the process, we can use a lot of data and data solutions that can help make physicians make better decisions. And so that's where I started first. And I was seeing that there's so much potential for these kinds of tools to help physicians, what we call clinical decision-making tools or clinical decision support. And so that's where I cut my teeth into innovation. And I saw that there's a lot of potential, but we are punishing the people, which is the physician and the nurses, instead of making the tools better. Punishing the machine, because machines have a lot of capabilities and capacities that we are not taking advantage of. And that's why I wrote Punish the Machine. And artificial intelligence has a lot of potential to make healthcare better and help better patient outcomes, while helping physicians and staff decrease their workload. And that's the gist behind that book.
What has been the most significant impact on digital therapy with patients' care?
So So some of the examples of my research, I would say, where, if a patient comes into the emergency department, right, they have some problem, but how to treat a problem, we went to medical school, we've read the books, and we've taken the tests and all that. But when it comes to real world, there's a lot of variation in disease processes. So how do you know what to do with a certain patient? If we know what is going to happen to this patient in the next 7 days, next 30 days, next year, next 10 years, if we can predict which way this person is going, we can fine-tune the treatment to that particular patient. And so that was the premise for my work. So predictive analytics, so predicting which way the patient is going. Is it going to get better or is the person going to get worse? And based on that, fine-tuning your treatment. That way you're more precise, you decrease the variation, and also you decrease the bad outcomes. For example, if somebody comes in with chest pain, are they going to have a heart attack in the next 7 days? I wish somebody can predict that. But, technology is able to do that. We have developed systems and programs that can actually predict, who is going to have a bad outcome, and based on that, recommend treatments. So that's how I got started, and that's the most fascinating topic for me. How can technology enable better care?
So what percentage of Silicon Valley medical is embracing this, do you think? And what is the holdup?
Oh boy, that's a big question. So right now, the tools that I developed, when I was working for this large healthcare company, I developed those tools. And luckily, they got adopted, and right now they're active in 21 hospitals in Northern California. So that's a big win. And we won some awards and all of that. About 1 million patients go through the system every year. And we published about 100 papers out of that work. And there are 14, 15 physician scientists working in that group after I have left. But the biggest problem is that in healthcare, there are systems that are set up. There are various stakeholders that have kind of implanted themselves within this system, and they don't like to see the change. So it's the business model of healthcare. For example, if an entity, whether it is a physician or a hospital or a clinic, they are reimbursed based on what is done to the patient, how much is done to the patient, right? The other end of the business model is they're paid based on what the outcome is for the patient. Whatever you do, it doesn't matter, but what outcome are you getting? So when there is a system where you are reimbursed based on what you do or how much you do, then you tend to do more, irrespective of the outcome. But if your reimbursement or your income is based on how the outcomes are, so you will figure out to bring the best outcome for that patient. And so that's where the business model of healthcare is where it is a big hurdle for us to be able to develop and design these kinds of solutions.
So Dr. Yuli, tell us about Sirica's system before we delve in further.
Sure. So one of the things that happened was that right after I took early retirement from my regular job, I went into a space, we call it a community building, right? So I started a company that was building a community of physician innovators. And so my quest was, of course, I want to encourage other physicians and other, technology enthusiasts to come up with new solutions. And I was always searching for something to do in the autism space. I have a daughter with autism, and so I have a very keen interest in improving the care, improving the processes, and improving the outcomes for these patients. And so I was always looking out for what can make these people better. And so I found a company, a group of people that were developing this technology where they were using a robotic exercise machine and virtual reality goggles and video gaming to make a system. They were developing it for stroke rehabilitation. And so I joined their team and I worked with them until they developed the prototype. It was very fascinating for me because it's not typical traditional medicine. It's not a pharmaceutical, it's not a therapeutic device, but it's more of a digital therapeutic. And so I was fascinated in this field, and I really studied it and helped them develop this device. And then when they were releasing the prototype, I took my daughter there and have her try the machine. And she tried it and she loved it. And that's when I said, okay, this can be useful and hopefully therapeutic for autism. And there are, a few symptoms we'll be targeting. So I took that technology, I licensed that technology, and I spun off Sirica Therapeutics to develop it further to help people with autism.
That's brilliant. So out of curiosity, tell me, is that still being used for people with Parkinson's?
That kind of technology, it's still in early stages of development. So the first use case was stroke. It could be used for many neurodegenerative and neurodevelopmental conditions. So autism, ADHD, all of those are neurodevelopmental conditions. And so Parkinson's, dementia, a stroke, all of those are, diseases that happen in older individuals. So yes, it can be used for many other indications, but right now, these are our target conditions that we are developing it for.
So how does your system integrate VR, robotics, and the like into gaming?
Yes, so that's the exciting part. So the robotics it actually looks like an exercise machine, but it's actually a robot. So when you're exercising, the robot, and you're sitting on a robot, it'll like a recumbent bicycle. And so as you're pedaling, it is tracking all your movements. As you're steering with your arms and hands, it is tracking all that. And when you're not able to move a certain limb, it will help you to move it. So in other words, it'll power up and move it. And it is keenly tracking on how you're making the movements. So that's number one. And then you're putting on VR goggles, right? And there's a game going on inside the VR goggles, right? There's an environment. And in that environment, there is a vehicle, and you are actually placed inside the video game. And whenever you ride this, that vehicle moves. So whatever happens in the game, you will feel it. And whatever you do will be replicated in the game. So it creates a deeply immersive state. So you're hearing the sounds from that environment. Your movements are exactly replicating. So for example, if there is a rock and you hit a rock, you will feel the jolt in the machine, on the machine you're sitting on. When you're going fast, the wind blows on your face, and so you feel as if you're really going fast. And so in those kinds of way, every sensation is replicated, from that virtual environment into real environment. And so you make that connection from the real environment into the virtual and virtual into the real. So what that does is that'll put the person into a deeply immersive state. So you'll forget about where you are right now. You're actually living in that environment. So the idea for that deep immersion is that when there is a challenge placed while you're in this deep environment, whether it is a physical challenge and a mental challenge. The mental challenge is playing the game. The physical challenge is you actually have to write it, right? And everything is controlled by software. And so we can figure out a way for this person to be 100% engaged in that. And it's fun, so they get engaged in that. We think that when you do that, new neural pathways are created. It's called neuroplasticity. So the brain develops new neural pathways when it is challenged like that, because there, you got to play the game, and so you're motivated, and there is an element of fear because you might fall off a rock or fall off the path, or you might hit a rock. So you're really, really focusing on it. So all your brain cells are functioning at a peak level, and that creates a system or an environment for neuroplasticity where new neural pathways are formed. And we think that will help with the symptoms of many of these neurodevelopmental disorders.
So I am familiar that UCLA, they're doing a lot of testing with kids with autism and riding bikes and doing other physical activities. But my guess would be I wouldn't want my child out on a bicycle, out on the road. And it seems to me, if the outcomes are similar, that you are able to provide an incredibly safe environment to really take this to the limit beyond what one would be able to do on a real bicycle.
Yes. Actually, I have a friend whose son can ride like 25 miles a day. The only problem is somebody else has to ride with him. So yeah, you're right. You can create that. And then you can control everything because it is software, right? You can make it as hard as possible, or you can make it as easy as possible. And because it is a video game, it is fun, right? When you accomplish a target and you go to the next level, you get this a hit of dopamine, which makes you get really excited about doing that, and you feel accomplished, right? And so as you go, since everything is controlled by software, you make it harder and harder. And so when you do that, you're pedaling harder, your muscles are working harder. And so you get the next hit of endorphins, like when you exercise, you feel this high and you feel that. So when it becomes a cycle where you're stimulating the brain in such a way that it has to form new neural pathways to improve your symptoms. And that's the hypothesis behind it.
A typical problem homeowners have when wanting to buy a new home is whether to sell first or buy first. Either way is risky. When ready to look for a new home, TradeMyHome.com, powered by Your Home Sold Guaranteed Realty, offers an upfront guaranteed cash offer on your current home. Are you moving in the next 3 to 6 months? Text PAIR to 408-740-7400 for a free and no-obligation professional equity appraisal report, exclusively for Nonprofit Stories podcast viewers. For more information, visit TradeMyHome.com or call 408-740-7400. Remember, at TradeMyHome.com, your home is sold guaranteed or we'll buy it.
So it looks like this technology is immense and it's covering quite a range, but can you tell us how the outcomes are being seen in autistic children as a result of this technology?
Well, it's so exciting, but we're still in the very early stages of development, of research and development. So last year we did a study looking at feasibility and safety, and so that's the first thing we need to do. As we develop these kinds of technologies, is it safe, right? People might think people with autism may not tolerate putting on VR goggles, may not tolerate sitting in this machine and buckled up, right? How long can this sit? So those are some of the questions that we wanted to make sure we answered before we develop it further. And also, will they have any bad reactions to it? Will they start throwing up or have seizures or something else, right? That's always a question. So we wanted to make sure. So we had nine people with autism try the machine, and this is a full range of disability. Some of them were very low functioning, some of them were very high, and everywhere in the middle. So everyone did great. The average time was on the machine was 28 minutes, which is ideal for us. Our program runs for about 20 minutes, but they can sit longer. And the VR goggles, the average time they had it on was for 18 minutes. So that's perfect. And most of all, when we asked them, how much fun did you have? They scored 9.25 out of 10. So average, that was, the satisfaction that they get. And every participant wanted to come back for more. And so that's a good sign that, they will comply with the treatment protocols and they're excited and it is safe and it's feasible. So now we're going to our next stage. The next stage is looking at efficacy. And that's when we target a few symptoms, and we created a protocol that'll last 4 to 6 weeks, 3 to 5 times a week. They come and do a session. And so that's how the study is planned, and we are waiting to do that study to look at effectiveness. We are targeting anxiety, we are targeting aggressive behaviors, and we are targeting sleep. So those are the symptoms we are first going to attack and see how it changes a person's life and how those symptoms get better.
Well, and once we're able to make their life better, then their families' lives become better as well.
Oh, yes. And, when they are more regulated and when their behaviors are better, they can participate in school and play and social life, their family life. Everything gets better. Otherwise, it's a very scary situation when you have a full-grown person in your house and they can be aggressive.
So given the spectrum nature of autism, how do you customize these programs for different children?
Good question. That's the beauty of this, software program. You can actually, our initial target is going to be, obviously the more severe cases, because that's where we think that we can make a big difference. But, each person will be tracking thousands of data points as they're doing the session, right? Because it is software, because it is in the cloud, we'll be tracking all these, parameters, data points, and then we will see how they progress on the machine. And comparing that with how they are progressing on their clinical symptoms. So with some analysis, we would be able to figure out, okay, which specific characteristics in the program are helping which specific symptoms, right? So if you do a large enough data set, you can tease those things out and focus on those specific areas. For a symptom A, you need to use program X, like that. And so since it is all software, we can easily customize it to individuals. So that's our plan.
So do you foresee this product being developed eventually for home use?
Good point. Good question. Initially, we're going to be placing these in clinics, schools, and daycare programs, and maybe employers, right? And then as we develop this, as we fine-tune it, we'll be developing lighter machines. And hopefully the cost of building something like this will come down with time. And then, yes, we ultimately want to be in the patient's homes at their, so that they can use it whenever they feel like, and it becomes very convenient for them.
So how are you measuring the effectiveness of the product with the children with autism?
Well, we have a protocol. Since we haven't done the study yet, so I cannot give you the details. But, like I said, we are targeting 3 symptoms initially: aggressive behaviors, anxiety, and sleep. So sleep is easily measured, with wearables, right? Anxiety, there are, validated scales for measuring anxiety, and so we'll do a weekly measure. And then aggressive behaviors also, there are measures of, how often do they have a meltdown and things like that. You can measure those, and that's what we'll be tracking when we do the study.
How do you support and integrate family members in this treatment program?
Good question. So a lot of, about 30% of people with autism are nonverbal, which means they cannot talk. So it is very important to have family members or caregivers also participate in the study. For example, if we ask questions and they can translate that, because they can understand the person much better than we can, and also be able to tell us how things are going, because the person themselves, they may not be able to answer. And that's when the families are very important. Also, the family buy-in is very important. They need to feel confident that this is something that, number one, will not harm their loved one. Number two, that there is potential for improvement, and be able to observe keenly how those symptoms are evolving. And if they're getting better, they should be able to report back to us. So the family is very, very important, and the caregivers.
How do you see the role of technology evolving in emergency medicine in the future?
So if you think about emergency medicine, I call it a place where healthcare has failed. In other words, you're not able to prevent this bad thing that happened to you, and so you end up in the emergency department. Another way of looking at it is, if you had good healthcare, right? Now, the way I'm defining healthcare is where you're not getting sick. So you're able to prevent sickness, then you should not be ending up in the emergency. If you don't have access to care, then you end up in the emergency. Or if there's no other place for you to go, on a weekend and your doctor is not there. And so if you improve the system and improve the preventive aspect of systems, then the role of emergency medicine is very small. And same thing with the hospitals. You end up in the hospital because you failed outpatient treatment, or you got really sick and we were not able to prevent you from getting sick in the first place. And so in the future, what's going to happen is that as technology gets better and better, as AI becomes smarter and smarter, we will learn a lot of things that we didn't know before. I would say half of the things that we do in healthcare right now does not make health better. Because we don't have a good way of studying health, we are continuing to do things that we learned in medical school that were published in papers. But what makes a big difference is the real world evidence or real world data. So let's say, for example, if you do a study of 100 patients and say drug A works better than drug B, right? But if you do the same study on 1 million patients, it may not be the same, right? Because there's variety, because the geography makes a difference, where they live, what kind of socioeconomic conditions. So you get much different results in different places, different populations. That's where technology is very, very good, in the sense that very useful, in the sense that you take the data and analyze it in the real world situation, and it can guide you to make the right decisions, whether it is medications, whether it is procedures, whether it is preventive aspect of things. What are the tests you need to do to prevent? What are the vaccines you need to take? All those things can be customized to the population and to the individual. And that's the power of technology, I think. That's how it will change in the future.
Do you see telehealth stepping into this in the future? Perhaps we have technology in our homes that direct us to our doctors and increase that amount of intelligence for what's going on inside to our doctor on a regular basis, perhaps, and preventing those trips to the emergency room. What do you think on that?
Yes, telemedicine will play an important role. The way I look at healthcare in the future, it's not going to be episodic, where you have to see a doctor once a year or once every 3 months or talk to the doctor every week or whatever, right? It'll be continuous. And the data tools will be useful and given to the patient for them to monitor and for them to intervene and not go into a path where, you get a bad outcome. So patients will be much more empowered to be able to do that. And you will see the doctor only if you're not able to handle it or you failed in some way. And so that's when the doctor will intervene. Otherwise, you should be able to manage with all the tools, with all the information, with all the technology that can be installed in the home. That'll be the future where patients will be, managing their health.
What upcoming projects from Sirica Therapy do we need to be looking up for?
Well, right now we are raising money. We are raising our, pre-seed round. Once we raise that, we're going to do the study. And we are looking at other conditions. Obviously, kids have various conditions. And mainly we are focused on the younger population in this case. And so whether it is, we think that this will help improve the behaviors, help improve anxiety. And so what's the next level? How can we help improve communication? Can we help improve, self-determination, where they're able to become independent, need less care than now? So those are the technologies that are fascinating to me. We're not going there right now because we have our hands full with what we're tackling right now.
What advice would you give parents and caregivers in looking for therapies and treatments for their children?
Being a parent of a special needs child is very, very difficult, very challenging, because I've been there and I'm still there. And my wife, we go through a lot of stress, especially when they're younger, because a lot of things are unknown. So since my daughter Siri was younger, and now she's a young lady, she's a grown adult, a lot of things have changed, right? Things have improved. People are, right now she's going to college, and that would have been unthinkable in those days when she was first diagnosed, because she didn't even know her name. And so a lot of progress has been made. And the good thing is that the progress in the near future is going to be, it's accelerating at an exponential speed, right? So more discoveries and more treatments and more better therapies and better treatments are coming. And so I'm very optimistic because the future looks very bright. There's so much going on in the innovation space that I'm really excited to see what the next 5 years, 10 years are going to bring. So I would say hang in there.
Thank you, Dr. Yuli, for coming and sharing so candidly, and for the brilliance that you're putting into our community to help each and every child with autism and beyond.
Thank you, Didi. Thank you for having me, and it's a pleasure to share my ideas and thoughts, and I really appreciate this opportunity.
Here's a sneak peek of the next episode of Nonprofit Stories, featuring Lisa Blanchard, the executive director of the Grateful Garment Project of Silicon Valley.
Oh gosh, there are so many common myths. I would say that probably the biggest one is that sexual violence is typically some woman, scantily dressed.
They aim to restore the dignity of sexual violence survivors by offering emergency aid post-forensic exams and supporting recovery from various forms of sexual violence.
It's not a woman, right? Most 9-year-olds are not doing any of those things. They're just trying to be kids.
Check out our next full episode on Wednesday at 5 o'clock Pacific and 8 o'clock Eastern on YouTube and Apple Podcast. Thank you for listening to the podcast and acknowledging the impactful work of nonprofits in Silicon Valley. Please subscribe and share this episode with a friend. Thank you to our sponsor, TradeMyHome.com, for their community commitment and for making this podcast possible. Until next time, remember to support local nonprofits.